Hello students, welcome to Mathematical Techniques with Gagan Mita. Today we will discuss MCQ series of CBSE class 10. Right? You know very well this is board class and board examinations are very near. So we start a very interesting and very important MCQ series. Right? Now discuss our first question. Our first question this uh, is square root 0.4. This is rational, irrational, integer, natural. What about this? Right? Now we know that this is very easy. Now write this as this, and here we after divide we get this is 2 and this is 5. We know these two both are primes. If we have a square root of any prime number, then we can say that this is an irrational number, right? This is an irrational number. Very interesting, right? This is the question of last previous year exam, right? Very important. Now we will discuss the second question. The second question is which of the following cannot be the unit digit of 8 raised per n where n is a natural number? Our option 8 raised per n. Right? Now here we find the unit place digit of 8 raised per n. Right? It means uh, from these all four options uh, we discuss which of the following is not a unit place digit of 8 raised per n. Right? Now we write 8 as that is suppose n is equal to 1, so 8 raised per 1 is 8, right? And n is equal to 2, that is 8 raised per 2 is 64, right? And 8 raised per 3, here we get this is 512. So here 4 is possible, 2 is also possible, and in further cases I know 6 is also possible, but we have a 0, that is we know that the digit that contains 0 at the unit place, that digit contain in factorization suppose 8, right? And factorization of 8 is 2 into 2 into 2. Here the only factor is 2. We know that the number in which the factorization contain 2 and 5 both, that number is and with digit 0. So its option is C. 0 is not a unit place digit of 8 raised per n. Right? Now we will discuss the third question. If HCF of HCF of 306657 is 9, right? And then find LCM of 306 and 657. Right? Now, here we discuss a very interesting concept, that is, we know that LCM into HCF is equal to P into Q. That is, LCM into HCF that is equal to product of two given numbers. Right? Here we know HCF is 9. Here we find LCM and we have given two numbers, that is, first number is 306 and second number is 5657. Right? Now, LCM is equal to 306 into 657. Now divide with these with 9. Now uh, here we after calculation we get this is 3 and now this is 4. Now multiply 34 with 657 we get this is 22338, right? Now, our fourth question is again very interesting. That is product of rational and an irrational number. What about its product? Right? Here we know that the product of rational and irrational is always irrational. Right? This is always rational. Now, here we discuss another thing, that is if both are irrational, both are irrational, then it's if we add these two irrational and subtract multiplication and division, then always we get sometime answer is sometime rational and sometimes time irrational, right? And but one number is rational and other is irrational. Then here, if the operation is any, that is addition, subtraction, multiplication, division, then answer is always irrational, right? That is in the case if the rational number is zero, then the product subtraction division is rational. Otherwise, for non-zero numbers, the product is always irrational. Now, question number 5, that is uh, we are two numbers, that is are in ratio 15 and 11, right? There are two numbers which are in the ratio 15 ratio 11, and HCF of these numbers is 13. Now we know that if the numbers are in ratio, then suppose number as, that is suppose P is first number, that is in the form of 15x, and the second number Q, write it as 11, right? Now here we find HCF. We know that HCF is highest common factor. In these numbers, we find the common factor, that is x, right? And HCF is 13. So x is 13, right? Now put this x in this number, that is 15 into 13, that is we get this is 195, and the second number Q is 11x, that is 11 into 13, that is we get 143. So our option is first A, right? This is very interesting. Now our sixth question is again very interesting, that is uh, if we have two numbers, that is A number is like x cube y square and B number is x square y cube. So here we find HCF and LCM, right? Now we know that what is HCF? HCF is highest common factor, right? In these two, firstly we find common factors. Here the common factors are x and y. Now here we set degree of these numbers, that is in HCF. Here we set the degree of common factors smallest, that is in these two, smallest degree of x is 2. So write here 2. And in these two, here the smallest degree of y is, that is 2. So again 2. So its HCF is x square into y square, right? Now in LCM, we know that LCM, that is common multiples. Here the common multiples are x and y, right? All factors that is common. We write LCM as common multiple, that is all factors which are possible in these two numbers, right? And highest power of these numbers, that is in x, here the highest power is x cube, and in y, here the highest power is again 3. So its LCM is x cube into y cube, right? Very interesting. Now next question is, that is find HCF and LCM of least prime number and least composite number. That is, here we know least prime number is 2, right? And the least composite number is 4. Here we find HCF of this, HCF, and then again find LCM. Now we know that HCF is common. That is in these two, common factor is 2, and LCM is, here we write 4 as 2 into 2. So LCM is 2 raised to power 2, that is 4. This is very interesting. And again here we add another question, that is here we find ratio of LCM to HCF, right? Of smallest least prime number and the least composite number, right? This is another question. Now that is LCM is 4, right? 4. Here we find ratio from LCM to HCF, that is HCF is 2. Now divide with 2. So our ratio is 2 ratio 1, right? This is again very interesting. Now our next question is again very interesting. Here we find the exponent of 5 in the prime factorization of 3 750. Here we find exponent of 5. That is, firstly factorize this. If we factorize this, we get divide with the 2, that is 18, then 7, then 5. Right now, divide with 5. Here we get this is 3 and 7, then 5. Again with 5. Here we get 7, again 5. Now, with 5, here we get 15, and then with 5, here we get 3. Now, if we write as factorization, that is 3750, write as 2 raised per 1, 5 raised per 3, sorry, 5 raised per 4, and then 3 days per 1. So here we find exponent of 5. That is, here the exponent, that is degree of 5, this is 4. And sometimes this question is write as find the sum of the exponents, right? Here the exponents are 1, 4, and then again 1. To add these, we get this is 6. Sometimes question is asking about the sum of the exponents. So here the exponents are 1, 4, 1. So add these all, we get 6. Right? Now next question is LCM is LCM is 14 times HCF. Right? Our first condition, that is LCM is 14 times HCF, and the sum of LCM and HCF is sum of LCM and HCF is 600, right? If the number is 280, if one number is 280, now find other number. Suppose B is the other number, here we find B, right? Now, uh, here we find this is very interesting. LCM is 14 times HCF, so put this LCM value of this LCM here. So we get this is 14 into HCF and plus HCF is equal to 600, right? HCF 14 HCF into plus 1 HCF, that is 15 into HCF. This is 600. Then HCF is 600 upon 15. Here we get this is 40. So HCF is 40. Now here we find other number, and we know that if one number is 280, other number is B, here we find B, and then HCF is 40. Then how we find the second number? This is a question, right? Now, firstly, here we find LCM, that is LCM is 14 times HCF, that is HCF is 40, so LCM is this is 56, 0, that is 560. Now, here we apply a formula, that is LCM into HCF is equal to A into B, right? Now, LCM is 556, HCF is 40, A is 280. Now, here we find B. Now, 560 into 40 upon 280, that is equal to B. Here we find this is 2, this is 80. Now, our second number is 80, right?